Hello everyone. In continuation with the triple integrals and after the lecture of cylindrical polar coordinates, just for cylindrical polar coordinates, I have explained in the polar and the cylindrical how the transition will happen, how the extension will take place. This continuation with that, I'll be dealing with the triple integrals example using the cylindrical coordinates. At the end of this session, you'll be able to convert the given Cartesian coordinate to cylindrical coordinate system. That means if the integral is given in terms of the Cartesian coordinates, the upper and the lower limit, you can able to convert that into cylindrical polar coordinates. And this is also, you can able to evaluate triple integrals over the given region using the cylindrical coordinates. Let us go for the first example. Evaluate the integral by converting to an integral in cylindrical coordinates. So this has been given to us. Now, as we are dealing always with the same, always look at the lower and the upper limit of each and every integral. Before that, just you understand which variables have been given. So I've been given z, y, and x. So these are the three variables been given to me. Now I need to check the innermost integral, what variable is missing there. Out of this three, which is missing? The missing one is z. If you'll observe, it's x square plus y square minus 11, that is z is missing. So I can say that yes, this is the limit for z. That means z is moving in between these two, that is x square plus y square minus 11 as a lower limit, and that means it is moving from this plane to the other one, this plane to other one. Then it is from from that minus 11 to this x square plus y square minus 11 to 9 minus 3x square minus 3y square. So this is for z. Now just consider the next two here. So whenever I'm considering next two, I have to consider this as my y. Why? Because z is already been converted, z is already been designated to the innermost. So this is y is missing here. So obviously this is for y, right? And the last is for x. So I've decided what are my variables. The integral variables are, what are those? So we have done that. So it's x, y, and z. Right now, let us, so if we'll observe, it's x square plus y square minus 11. So if I will just combine this x square plus y square, and we have seen the cylindrical coordinate system, x square plus y square will give me r square. This will give me r square here, right? And now if we'll just combine these two, if we'll put this in two brackets, so it will give me 3 bracket out, and in the bracket x square plus y square, it's nothing but 3 r square. So I'm going to get this as r square. So if you observe, the limit for this z in the cylindrical coordinates would be, because I want in the cylindrical r, theta, and z. So I want this 3, right? So I'm just converting everything in terms of, so x and y I need to convert in terms of r, theta, and z respectively, right? So this is, so I have got a r square minus 11 less than equals to z less than equals to 9 minus 3r square. So this is what is the limit for my z here. What will happen? What is the next is? Next is I need to consider the limit for y. Y is, if you'll observe, this minus square root of 5 minus x square less than equals to 5 less than equals to 0. That means the lower limit is on the curve y. So if I wanted to find out, this is nothing but y is equals to this minus of square root of, so if I wanted to remove that, is nothing but y square plus x square is equals to, right, is equals to 5, is equals to 5. This is, I'm talking about the lower limit of this y, lower limit of this y. So what is this? This is nothing but a circle. It's center at origin. So this is what is the circle with center at origin, and radius as root of pi. Radius as root of pi. Now if you observe, this minus square root of 5 minus x square is, what is it? Which part is this? This is minus. That means this is a lower part of the circle. That is x-axis, the lower part of that. So that means this is nothing but this entire region here, right? Entire region here. So it is moving, because if you'll observe this, just you concentrate on this two part. This is given to me as integral x and integral y. So innermost integral is for y. That means I need to consider in a Cartesian coordinates a strip parallel to y-axis. If I'm considering a strip parallel to y-axis, my lower limit is on this circle, but with the minus sign. That means it is in the lower part. So suppose this strip is moving something like this here, something like this here, right? Right. But what is happening here? What is happening? I have to take care of my x also. What is x? X is given to me as from 0 to square root of 5. That means what? This part of this circle will not be coming under the consideration, because if I'm saying x is equals to 0, x is equals to 0 means my y-axis. X is equals to 0 is y-axis, right? So my restriction for this is, sorry, so my restriction for this is y-axis, right? To this point, or the line is x is equals to root of 5. So that means this somewhere here, this will be somewhere here in between, this will be the region. If this is the region, okay, just let me just erase this, because it's already got so many things over here. Okay, so one thing you must have understood now. So I have got it here. I have got it. The region, the restriction is this axis. So I want my region from this to this, only this to this. That means this is a line, x is equals to root of 5. I want the region between the y-axis to the line x is equals to square root of 5. So if it is so, and the lower part is this, lower part of the circle I have to consider, because this is already got discarded. So what would be that? What would be that? And I'm considering a strip parallel to y-axis here. So if I'm considering a strip parallel to y-axis here, and my restriction is here, and if you could see that y is not moving greater than 0, right? That means this strip will have to end here at x-axis. So if you'll observe, this is what is the region here. This is what is the region, and therefore I could say that I could do this. This is my region under the consideration. Now, if I'm doing, this is the region under the consideration, and how can I do that? How the limit will vary from here? But I need the limit of this region in terms of r and theta. In terms of r and theta, right? So this is the region in the fourth quadrant. Fourth quadrant. So r will move from any point on this circle. Any point on this circle. Any point on this circle, right? But what is it? This is nothing but the r will move from 0 to square root of 5. So if I will draw here a ray, now we don't have to draw here. We don't have to draw here. This is the strip. I have to draw. I have to go for a ray here. A ray here. See, this is a ray here. So this ray will move from 0 to this circle. This circle is nothing but square root of 5. Square root of 5. It's very simple. This is y square plus x square is 5. Therefore, nothing but is r square is equals to 5 and r is equals to root of 5. Right? So we have got this, the limit for, and how the theta will move. What is this theta here? Theta here is 3 pi by 2, right? And this is theta is equals to 2 pi. So my theta will move here from 3 pi by 2 to 2 pi, because this is a fourth quadrant. We have got this theta, the part of theta is. Therefore, this is what is the limits of this entire integral. Okay, then this is an integral has been given to us, and after this we have to just convert x is equals to r cos theta, y is r sin theta, and z will remain as z, and then we'll just put the upper limit and the lower limit of these three variables. That is, this is what I'm just talking about, and therefore this is like theta is from 3 pi by 2 to 2 pi, r will move from 0 to square root of 5, and z will move from r square minus 11 to 9 minus 3r square. And therefore this is, and again this is conversion, x is replaced as r cos of theta, y has been replaced as r sin theta, and then this dx dy dz is nothing but r dz dr d theta. And after that, just a usual integration you need to go for. So if here, this is, if you observe here, this is, we are doing, this is the limit, we have got it for z first. So we are just removing, always you have to keep the last integral or the outermost integral as a constant. It's not required that you have to fix it up to theta or fix it up to r. It's not required. You can just go ahead, like swapping can be done. Only the thing is, because I need the final answer as a constant without a variable, I cannot place my z from here to the outermost, because otherwise what will happen after, at the end of the step, I'm going to get the answer in terms of this r. which is not required here, which is not the goal of this. The goal of this is find out the integral in terms of a constant. And therefore, we are just doing this z first and then r and then theta. Just go through the steps. So the this there is no z in this. So z, this is limit is z. We are putting upper and the lower limit. After putting at the upper and the lower limit, we are going to get 20 minus 4r square, and this will be the same because it's a constant with respect to z. Then this 20 minus r square is getting multiplied with r square. It is 20 r square minus 4r to the power 4. Now it will be getting integrated with respect to r. The integration will give you 20 upon 3 r cube minus this 4 upon 4 by 5 r to the power 5, and the limit is from 0 to square root of 5. After putting the limit, you are going to get this as a constant, 40 by 3 square root of 5. Because why are you are going to get a constant? Before that, if you'll observe, I have got the limits of z after putting upper and the lower limit in terms of r here, right? But why? What was the reason? Because my upper and the lower limit was there in terms of r. Now here, if you'll observe in terms of the r here, the limits are from 0 to square root of 5. And therefore, we have got the constant here. If you'll observe here, this is a constant we have got after the integration with respect to r. And then we will just do the integration with respect to theta. And after that, we are going to get as 200 by 3 square root of 5 as the answer. Okay, the next question is evaluate triple integral 4xy dv, where E is the region bounded by this and the, so we have been given two curves here, right? Now, if we'll observe this z and this z, can you able to just understand the limit of z here without knowing the curve? It's not required to have a curve, the idea of curve in the first go, because whenever we have been given the limits like this, it's not required to have a curve in hand. But yes, you can easily do it. But yes, it's always good to have a curve with us. So it's z equals to 2x square plus 2y square minus 7. So suppose I wanted to find out the limit of this z, how that limit would be. So if you'll observe this 2x square plus 2y square minus 7, so it is nothing but I'm going to get my limit as, so what is it? This is limit from the lower limit and the upper limit. Why am I saying? So z equals to 1. If you'll observe this z equals to 1 will be somewhere here up, z axis somewhere here up. This is a plane, or you can say a plane which where the z equals to 1, z is always 1 on this plane. So x and y will move around, but this z will remain as 1 everywhere. So this is what we have done it, and therefore this is the paraboloid. If you'll observe this paraboloid, this is 2x square plus 2y square minus 7, and if you'll observe, this is what is the lower limit of my z. The z will move from this, say the region on the this paraboloid, and what is the restriction? Restriction is my z equals to 1 plane. This is the restriction of my z equals to 1 plane, and therefore if you observe, this is the limit. So just as per the previous, this is we have been replaced as x square plus y square, we have been replaced as the r square, and this is 2r square minus 7, and this is the limit for z, 2r square minus 7 less than equals to z less than equals to 1. So z will move between these two only. So what is this? My first is this, the lower end of this paraboloid, and this upper end is on z equals to 1. Now if you'll observe this entire figure, what we have done it here, this is x is equals to 0, and okay, for a while just let us stop for this. Let us find out this z. Z is from 1 to 7, if you observe. Z is equals to from 1 to minus 7. So that means what? This paraboloid is nothing but a bowl have been kept it on the ground. The ground is nothing but at 7, minus 7 unit of z axis. Like this, if you could understand that. Okay, then look at this. This is nothing but here, and this is what? Now you have got two options here to find out this x and y limit. One is you can just go above on this and look at the curve from here, look at the curve from here, look at the curve from here. If you'll observe here, if you go on a top of this curve, and if you observe this curve, you will get a circle. You will get a circle in x and y plane. You will get a circle in x and y plane. What will be the radius of the circle? The radius of the circle, or the center of the circle, you can easily get it from this equation just by putting z equals to 0. What is it? I'm putting z equals to 0 in this equation. One more thing I have got it here, and therefore this is, and I have got one more thing, that is z equals to 1 here, because it's not on the origin, it is 1 unit away from z, and therefore just we have to combine these two equations. After combining these two, because I'm just eliminating my z out of it, out of these two curves. How? So this z equals to this equation, this is z equals to 1. So therefore 2x square plus 2y square minus 7 is 1. So 2x square plus 2y square is 8. And therefore my x square plus y square equals to 4. So that means what? This is nothing but a circle in xy plane with this, with the radius as 2 unit. If you'll observe, that is what I have just stopped at that point. If you'll observe, this is what is, right? This is the origin and this is 2 unit. And if you'll just put the projection from this here, from each and every point of from this paraboloid, you are going to get one circle over here, one circle over here, right? Like this, a circle over here in xy plane. So this is of 2 unit and it's an entire one circle. So what is r will move from 0 to 2, because this is nothing but each and every point on this curve, on this circle we have to. So suppose I'm just drawing, sorry, I'm just drawing one ray over here. This ray will move the lower end is on origin, that is 0, always a source, and the upper end is always on the circle x square plus y square is 4, which is nothing but r is equals to 2. And what will be the theta? How the theta will move? Theta will move from 0 to 2 pi to complete one circle, and therefore the limit is this, and therefore the limit of this is equals to let me just put it here, should not get confused here, and this is what is the limit. So limit for this particular curve is r is from 0 to 2, theta is from 0 to 2 pi, and z is from 2r square minus 7 to 1. Okay, and therefore what will be happen? So this is what is the, as just for a reference sake I have put it on the slide, and this is triple integral 4xy dv is, I'm just replacing x as r cos theta, y as r sin theta, z as z only, and the limits 0 to 2 pi, 0 to 2, and this is the limit. Now if you'll observe here, we have to go for z for first again because here we have got it 2r square minus 7 as the lower limit. That means what? Here there is the vector, other variable is present, that is small r, and therefore this integral we have to take it as the innermost, so that it will get rid, we can get rid of the variable out of this integration, and then it will be easy for us to put upper and the lower limit. Okay, so it's 4, I'm integrating with respect to z first, and therefore it is just because there is no z present, and therefore just one z will come here. Upper and the lower limit will give you this, right? Combining with this 4r cube, and therefore we are getting this, then integrating with respect to r and then integrating with respect to z, you'll be getting the answer as 0, right? You'll be getting the answer as 0. And this is what is the triple integral over the cylindrical coordinates, right? Now I have done one commitment whenever I have given you the lecture on cylindrical coordinates, that I'll be explaining you the modified cylindrical coordinate system, how the problem will look like. Let us go for this type of this is the example where I wanted to give that particular thing here. So evaluate triple integral e to the power minus x square minus z square dv, and this is the region between the two cylinders. X square plus z square equals to 4, and x square plus z square equals to 9, with y limit and with z as the limit, right? Now, if you'll observe, what is this? This is nothing but x square plus z square 4, and this, what are they are the cylinders with radius 2 and 3. Observe this radius 2 and 3, the equation of the cylinder with radius 2 and 3. And what is the center? Center is on y-axis. Why center is on y-axis? Because if you observe in both the things, these points of this cylinder are varies with x and z. With x and z, y is absent there. That means what? This is, suppose here now. This is now let us consider because we have a traditional way of thinking that always my the axis which is there around cylinder. So if you'll observe, this is my y-axis, and this y-axis way I have got two cylinders, one cylinder here and around that another cylinder. So inner cylinder is of 2 unit, another cylinder is of 3 unit. So this is what is the cylinder of here, right? Now what is the another restriction I have got? The another restriction is that y, that the cylinder will move just for 1 to 5, 1 to 5. So this is got 1 to 5. So cylinders, just you assume that I'm wearing a bangle of this size 2 and 3, the bigger bangles, the 2 and 3 unit, and this the width of those, like how many number of bangles, or the bangle, or that this is just 1 to 5, that much is unit. So cylinders in the range of y's. So this is nothing but the range of y has been given, and this z is less than or equals to 0. What is significance? This is nothing but the lower half of the cylinder. That means we don't want to consider the z greater than 0 part of that cylinder. So it is getting cut by z equals to 0 part. And if you'll observe, this is what is the cylinder. Right now, if you'll observe here, instead of always we are dealing here always with z as the axis, as the above axis or this axis. This is nothing but around, and this cylinder is lying in my x, and this is a z plane. If you'll observe, this is xz plane, whereas this is the y, right? This cylinder lies is here, xz plane here, right? So now I think no, it's just a minute. Yeah. So this is my this is x, and this is a z. This is xz. We'll observe here. Yeah, this is the xz plane. So this is what is the xz plane. So if you'll observe here from here, so xz plane needs to integrate with respect to y first. Why? It's also in the previous two examples we will be having this scenario a little bit different. Always we will used to have other two examples. We used to have the curve in xy plane. At that time we used to integrate with respect to z first. Now here in this case scenario, we have got the plane or this surface in xz plane, and therefore we need to this integrate with respect to y first. But how can we do that? Again, we have got I have to just look at the curve from y-axis. Now this is what is my y-axis, and if I'm looking at, so suppose if this is what is nothing but a y-axis here, right? This is nothing but a y-axis here. So if I will look at the curve from this side, from the y, that means I'm going above of this curve and looking at the curve from here. How that curve will look like? The curve will look like this. If you observe, this is nothing but the circles, the two concentric circles with the origin as the center and 2 and 3 units as the radius. Now one thing you can observe here, instead of this here I have got a z, because this is nothing but in xz plane. Normally we are always dealing with y and x. Now but here in this example it's known as a modified. There the role of z axis has been replaced as y. The role of z axis has been replaced as y. Okay, so this is a 2 unit, this is a 3 unit, and we wanted to find out this the x. This is what is the z here. This is what is the z here, and we wanted to find out this integration now, just using the double. So what will be my modified version of this? Version of modified y will remain y, because if you'll observe, the z axis has been replaced as my y. So if you'll observe this, y will be as it is y. And what will be that? Which role has been replaced? Z and y has been replaced. So the equation of which we were having y is equals to r sine theta, now it's been given to z. Automatically it will come because of this, the modification, or you can say the placement of this curve over here. So z is r sine theta, x will remain same because x is present there. So x will be r cos theta, y will be equals to y, and z will remain as r sine of theta. So z is r sine theta. So this is a swapping between x and this sorry y and z axis, if you observe the formulae also, right? And then again we have got this restriction, that is y is moving from 1 to 5. And then what is this? Because we wanted to have, suppose I'm just drawing a ray over here. If I'm drawing the ray over here, which ray I need to consider? Do I have to consider this part? Oh, sorry. Um, so if I'm starting from here, just consider that I'm starting the ray from here and here, but this will come here, because this part I don't want to consider. Then again this will come here and this part will come here, right? So this is what is the ray, right? The ray is from here. So how about this will go? This will go from the innermost circle, which is r equals to 2, to the outer one. So r will move from this 2 unit 2 circle to unit 3 circle, the radius 3 unit circle, right? So r will move from 2 to 3. And how the theta? Obviously theta will complete, because this r will start from this point. So this point is theta is equals to pi, right? So this is theta is equals to pi, and it will complete this half circle here, and it will reach to this point, which is 2 pi, and therefore theta will move from pi to 2 pi, and which are the limits for this particular integral. And again, modified version, it's very important to understand the modified version here. And if this is what, so accordingly my variables will move. If you'll observe, until now we did not get any z into the other two variables. Now here we did not have a y over here in the integrand. If you'll observe here, in the integrand, if you'll observe, we have got e to the power minus x square minus z square. Y is absent. In the previous two examples we were having z absent, right? Here this is the change. You can have this also, this you can consider this as also a clue for this particular modified cylindrical coordinates, right? Okay, now the limit is pi to 2 pi, 3 to 2, and then 5 to 1 to 5. So now here if you observe, all of them are constant limits. So it's up to you which variable you wanted to go first for. It's not required to have to go for y only, or go for r only, or theta only. Its flexibility is completely towards the solver, whichever, but definitely the answer will remain same. Whichever the integral will be doing first or second or a third, doesn't matter, the answer will remain same. Now again this integrand e to the power minus x square plus z square, if you observe, this is r, this dy, dr and d theta is nothing but my this r and this 3 will be they are the volume element of this particular modifier. And this e to the power minus x square minus z square is nothing but e to the power minus r square. If you'll observe, because my circle, this previous step, the circle was in x and z plane. Therefore, the r square here is nothing but x square plus z square. Here r square is nothing but x square plus z square. Remember, it's not x square plus y square. So it's x square plus z square. And accordingly, we are replacing this here. So if you observe here, it's e to the power minus x square minus z square is e to the power minus r square. And then it's been just a integration. It's a constant, as I've told you, it's a constant. You can just go for any variable. Now here I have gone for y first, and then I've gone for r, and then I've gone for theta. So it's the sequence doesn't matter at all whenever the limits are constant. And we have got the answer as 0.1143, which is nothing but 2 pi e to the power minus 4 minus e to the power minus 9. And just you use a calculator to get this answer here, right? So this is what is about the cylindrical coordinates, finding out the triple integrals using the cylindrical coordinates. Most of the times we will be dealing with the cylindrical coordinates whenever we are having this circle and a cylinder kind of combination. And that means what, most of the time it's a circle and a cylinder kind of combination we will be having. That time we'll be going for cylindrical coordinate system. I hope you have understood this lecture. Before going for this session, I'm requesting you to go for the previous, that is for just for the cylindrical coordinate system, so that you will understand it very well this particular session. I hope you have understood this. Thank you. Happy learning.